Hello students. So continuing the discussion on the composite material. So we have seen how the composite materials are classified. So what are the characteristics, advantages, disadvantages, and a few characteristics of a metal, that is matrix based composite and a reinforced based composites. So moving on with the discussion. Here we stand at an important stage, so where we need to understand the processing of the composite material. So how exactly we are going to manufacture, or in other words, process those things or produce those things. Okay. So as we have seen in the classification itself, so the composite material are having a variety of a classification. So each classification so depends or needs a particular method, okay, a processing method. Why? Because see, so when we are going to have a fiber, the L by D ratio is a different. So when we have a particulate, then the L by D ratio is a different. When we are going to produce the laminates, the requirement or the property which you are going to get are different. Means so depending on the type of the fiber which we use, and even depending on the matrix. Say for example, we cannot apply the same processing method which we use for a metal to the plastic, or which we use for a ceramic to the plastic. Okay, so already we know what are the characteristics of a metal matrix composite, a polymer matrix composite, and a ceramic matrix composite. So the processing temperature differs, okay, and the pressure which it can withstand is a different, okay, and the molding methods are a different. Say for example, if you take a plastic, the melting temperature or the temperature at which it gets softened is a different compared to the metals and compared to the ceramics also. Okay, so we say ceramics are having a high temperature withstanding capacity. Okay, so compared to these metals and the plastics. Okay, so like that. So the processing method depends on the type of a matrix and the reinforcement which you are going to choose. Okay, so even in the polymers also we have seen, so there are thermoplastics and the thermosets. So even in that category also, so the temperature at which these get softened or get hardened, so everything is like depending on their bonding method also. Okay, so depending on their chain, a linear chain or a two-dimensional or a three-dimensional, like that. So means depending on those things, so one has to choose wisely. So what type of processing method they are going to adapt for their processing of the composite material. Okay. So moving on with that one. So there are plenty of methods so which are available. Okay. So a simple to the complex. Okay. So depending upon that their requirement. Okay. So selection of a particular manufacturing process based on a type of matrix or a fiber or a temperature to form. Okay. So the two important parameters that control the manufacturing techniques are temperature and the pressure. So as we mentioned, so the processing temperature, or you can say like the operating temperature at which you are going to process these composite material or manufacture these composite material is a totally different. So high temperature is required for the chemical reaction resin to prevail, whereas the pressure is required for highly viscous resin, okay, to flow into fibers and to bind fibers which are initially unbonded. Okay, see compaction. Okay, so we need to compress or we need to apply a pressure so that so there will be impact between the matrix and the fiber material. Okay, so which gives a proper interface, thereby giving a high strength to the composite material. Okay, so the chemical reactions of a resin forming cross links is called a curing. The time required to complete the curing is also called as a cure time. Okay, means so if you are going to use a thermosets and all, okay, the curing time it may require little bit more. Okay, so if we have the same thing with the thermoplastic, the curing time and the temperature which we require may be less. Okay, so depending upon those things, So depending on their curing time and a curing cycle, so one has to choose, okay, so what type of processing method they are going to choose it for a composite material. Okay. So moving on with that one, how exactly we are going to classify the processing methods. Okay, so as we discussed, it depends on many factors. So here, these processing methods are classified on the basis of the method in which we are going to process it. Say, for example, the type of a mold. Okay, whether it's an open mold or a closed mold. Okay, so open mold means we are going to have a mold which is the top is open to the atmosphere. Okay, so where we are going to pour the liquid matrix and placing the reinforcement, and it gets hardened, and then we are going to get the proper shape. Means the mold is going to decide the shape of the component which you are going to get. Okay, or else in other words what we can say, like the mold is prepared keeping in mind like what type of product you are going to get, or the shape of the product which you are going to get. Okay, so that is what in that one we are going to have a spray layup. Okay, so and layup, filament winding, sheet metal compound, that is SMCV normally called as, so expansion tool molding, so contact molding. Okay, so when it is in order to eliminate the disadvantages associated with the open mold, so then we go with the closed mold process. Okay, so where few disadvantages are eliminated. Okay, so we are going to get a few advantages. So example for a closed mold process are a compression molding. Okay, so vacuum bag molding, pressure bag molding, and autoclave, and injection molding, and a resin transfer molding, or we can call it as a RTM also, resin transfer mold process. Okay, so these are like a one method. Okay, these open and closed mold methods are one way where we have to wait till a product is cured, then we can load for a new one. Okay, it is not something like a continuous process. So if you want to have a continuous process, then we go with the pultrusion or braiding. Okay, so then, so depending upon whether you are going to have the or process the composite material in a liquid or a solid state, we call it as a liquid state fabrication. So stir casting, infiltration, okay, which normally we use for a metal matrix composites, solid state fabrication, so diffusion bonding, powder processing or a powder methodology, so which are very famous for metal matrix composites. So deposition technique like a spray forming, electroplating, spray deposition, chemical vapor deposition. So where, so if there is a processing difficulty in processing the ceramic material or a metal materials, okay, at a high temperature, so then we go with the depositing the what you call the reinforcement material or maybe the matrix material in a liquid form on a substrata. Okay, so those are categorized as a deposition techniques. So in situ fabrication techniques, so while processing itself we can form the required material. So two-phase process, we call it the spray deposition and a compo casting. Okay, so if you go on listing, as we said, so depending upon the types of fibers and types of matrix normally we are going to use, we will get a plenty of methods. Okay, there will be a little bit modification depending upon their requirement and age of what you call processing. Okay, so if a process is designed for processing of some composites, so there may not be a thumb rule like it has to apply for a same material or like a same category of material. Okay, so it depends. Okay, so one can alter the process depending upon their requirement to get the desired properties and product. Okay, so like that. We have a plenty, but in our limitation, so we have a few things which are chosen from each category. Okay, so and we are going to discuss so how exactly that processing of a composite material is done and what are the limitations regarding that process. Okay, so advantages and disadvantages associated with that one, and to eliminate the those disadvantages, so is there any other process which is available in the uh, present scenario. Okay, so like that we can see plenty of processing methods for composite material. Okay, so in that one, we'll go with the simpler process to a complex one. So where we can see a method which is there for producing a single component to producing a multiple or a continuous process also. Okay, to understand so how exactly these processing of a composite material plays an important role in the properties. So first we'll go with the open mode process. So in that one we are going to discuss with the hand layup process. Okay, so many times while discussing the topics in this course, so I have told, so just look into the word. Okay, that is a topic. Say for example here they say and lay up. Okay, so and lay up. Okay, lay up means one above the other. It is like a stacking process, and it is done by the and. Okay, so and lay up process. Okay, so all these whatever the layups and all, so done by the manual process, and a pressure is applied in order to get a uniform thickness, and we are going to have this one. Okay, so when we look into the process picture, so this is how exactly it is visible. Okay, so just for a simplicity they have taken one dovetail mold. Okay, so we can say this is a mold. Okay, so this is a mold, and this is the shape of the product which you are going to get. Okay, and the thickness and uniformity of that one again is controlled by the human. Okay, human being, that is it is a hand operated. Okay, so they like whenever there is a interference of a human being, so again we say like there are errors. Okay, so in order to eliminate that one we can go for a automation also. So how exactly we'll see, so we can go through that one. Okay, so the process starts like this. So designing the mold. Okay, so depending upon the product which you want, so according to that one the mold is designed. Okay, so this is the open mold. Okay, open to the atmosphere. So once the mold is designed according to the shape which you're going to get, so first thing is to have the mold, the surface of the mold covered with a gel coat. Surface of the mold is covered with a gel coat. So this is going to facilitate in order to remove the end product easily. Okay, so which will help to strip the final product from the mold surface easily. So if you're not going to use the gel coat, what will happen? Okay, so you're going to just directly pour the resin on the mold surface, and it is going to get stuck to the mold surface, and whenever you're going to remove, so it may get binded to this one, or there may not be a good surface finish which you're going to get at the end of the process. Okay, so in order to ensure easy removal of the end product, a gel coat is applied so above the mold surface. Okay, so once the gel coat is applied uniformly over the mold surface, the next thing is pouring a resin. Okay, a uniform layer of resin is poured on the gel coat. Okay, so then above that one, so we are going to place the fabrics, that is a reinforcement. Okay, so either it may be a continuous one, or it may be in a matte form. Okay, or it may be in a tape form, or it may be in a discontinuous forms also. Okay, it again depends. So it may be a chopped strand, or oven cloth, or a mat, so which is manually laid over the a layer of a resin. Okay, so once the fiber is uniformly spread over the resin, okay, so once again one more layer of resin is poured on the fabric. Okay, so again sometimes what will happen, many times what we'll do, so first once the gel coat is applied on the mold surface. Okay, so directly they are going to place the fabrics, that is a reinforcement, on the gel coat, then they are going to pour the resin directly on the over the above or over the reinforcement material. Okay, so you can have it in that way also, or you can have it in this way also. Okay, so having a layer of resin below and above, so will ensure that there is a proper wetting of the fabric material, that is a reinforcement material, by the matrix or the resin. Okay, so once this process is done, so we are going to take a roller. Okay, and we are going to roll that one above these sand, which are a combination of a resin and a fiber. Okay, so uniformly. Okay, just to make sure that okay, so there will be a compact action. okay, or there will be a squeezing action, okay. So excess resin will come out, and there will be a proper bonding between the fiber and the resin. To ensure that one, these rollers are made to roll over these sandwiched compaction, that is a reinforcement and a matrix material. Okay, so even this will ensure to remove the entrapped particles. Okay, so if there are any air particles which are trapped in the resin and the fiber, so when we are going to roll this one, so those air particles are trapped particles also removed. Okay, so that will ensure the strength of the composite material also. Okay, so here the normal matrix which we are going to use are a epoxy, okay, polyester or a phenolic resin, okay, so which are mixed with the catalyst, okay, which is going to accelerate the process. Okay, so in order to accelerate the process or in order to soften the resin, okay, so which will be helpful in compacting the reinforcement with the matrix also. So in order to ensure that one, so the resin is mixed with the catalyst normally. Okay, so then after all this process, the mold is allowed for a certain duration to get cured. Okay, so when the process is complete, so we are going to take it out of that one with the help of a gel coat. Okay, and we are going to see, or we are going to check for the what you call proper bonding of the resin with the reinforcement material. A simple process. Okay, so most of the composite materials, okay, so are processed initially with this process only. Now, when we look into the advantages and the disadvantages which are associated with the hand layer process, okay, so a large and complex items can be produced. Okay, design flexibility, tooling cost is low, design changes are easily affected. So sandwich construction are possible. Semi-skilled workers are needed. So high for fiber content and long fibers than with the spray layer process. So that we'll see. So we can have a continuous as well as a discontinuous fibers. So what are the disadvantages? So only one molded surface is obtained. So quality is related to the skill of the operator. So low volume process, longer cure times required. Resins need to be low in a viscosity to be workable by hand. Okay, so this generally comprises their mechanical and thermal property. The waste factor can be high. Okay, so means so whoever is going to operate, he should have a knowledge about this process. Okay, so because see, laying of these fibers, okay, applying a compaction or a squeezing or a roller on the at the end of the process is going to ensure the quality of the composite material which you're going to get it. Okay, so means if he is a skilled labor, okay, so that will be an advantage to this process. Okay, so when it is open to the atmosphere, so there may be chances like so there may be contamination of the mold. Okay, so when we are going to leave it for a curing, okay, and even it takes a long time, okay, longer curing time, so which we need to wait, okay, until the process is complete, then we have to remove in order to get the products. Okay, so normally this process is applied are used to manufacture boat hulls, okay, tanks, building panels, okay, architecture moldings. Okay, so wherever it is required to get a normal application products which may not be a need for a high strength composite material, so there we go with the hand layer process. Okay, so next one will be spray hub process. Okay, so whatever the disadvantages we have seen it in the hand layer, so in order to eliminate that one, so there is a process called a spray up. Okay, spray up. So here the resin is mixed with the fibers. Okay, it is sprayed against a wall. Okay, so now the wall is nothing but a mold. Okay, so in the picture you can see here, okay, so the mold is kept in a vertical direction like this. Okay, again here the shape of the mold is going to decide the shape of the product which you are going to get. Okay, so that's the same, similar to the hand layer process. So here also, so we are on the mold surface we are going to have a gel coat. Okay, so which is applied just to ensure that the easy removal of the product. Okay, and to have a good surface finish at the end of the product. Okay, so once this mold is prepared, so then the next thing is, so we are going to have a three what you call nozzles here. Okay, so in the two nozzles we are going to have a catalyzed plastic resin. Okay, so the resin is mixed with the a catalyst, so which is going to accelerate the process. And at the middle one, so we are going to have a continuous strand rolling fibers, the a reel of a fibers which is mounted here. And at the end of this a fiber rolling component, so we are going to have choppers. Okay, so choppers are mounted in order to cut the fibers to a required length. Okay, so you can see the action at this end of the nozzles. Okay, so from the top and the bottom, so there is a spray which is continuously spread over the these what you call discontinuous fibers. Means so there will be a action where these discontinuous fibers are mixed with, or they are taken along with the resin, that is a catalyzed resin, and they are sprayed against the mold wall. Okay, so they are forced to go and stuck to the wall. Okay, so now here the length of the fiber are controlled with the chopping mechanism. Okay, and the amount of the resin which you are going to spray, or which is mixed with these chopped fibers, are controlled with these spray guns. Okay, so you can say like a chopper, spray gun, so fiber reinforced composites, so which is spread against the mold wall. Okay, so here normally this is suited for a discontinuous fiber, so where fiber is continuously chopped to a length. Okay, so depending upon the requirement of this one. Okay, so then when we are going to spray this one, so we can get a multiple layers. Okay, so once one layer is completed over above this one, so we can have a one more layer like that. So depending upon the thickness of the wall, or the thickness of the component which you want. Okay, so normally curing is done at a room temperature. Okay, or maybe it may be transferred to a what called a furnace, so where a curing time is reduced, okay, by heating to a high temperature. Okay, so in this process, okay, so again the sometimes, okay, so once we finish the process, rollers is applied by a manual method. Okay, that is a by hand, a roller is rolled over this one in order to ensure the compactness and in order to remove the air trapped during the spray process. Okay, so just at these corners, okay, or maybe at complex shapes and all, so there we can go and we can apply the rollers to eliminate the air entrapped in between the process. Okay, so this is an improved version in this one, so where we can control the what you call the amount of resin and amount of the discontinuous fibers. Okay, so normally which you are going to spray against the walls. Okay, so now what are the advantages? Okay, so it is a very economical process, making a small or large parts. So it utilizes a low cost tooling as well as low cost material. So it is suitable for a small to medium volume parts. So limitations, not suitable for making parts have a high structural requirement. Okay, difficult to control the fiber volume fraction as well as the thickness. These parameters are highly dependent on the operator skill. Because of its open mode process, stearine emission is a concern. So whenever we are going to spray the resin material, so it may get like maybe deposited on the outer world also, or maybe it is a health concern to the operator also. The process offers a good surface finish on a one side and a rough surface finish on the other side. Okay, so that is what when we are going to spray against a wall. Okay, so the surface which is in contact with the mold surface, we will get a good surface finish, and the one which is outside, okay, at that surface, the surface will not be having a good surface finish. Okay, so to ensure that one, so the rollers is applied externally, okay, in order to make sure that one more surface is a we are going to get a good one. Okay, the process is not suitable for parts where dimensional accuracy, process repeatability are a prime concern. Okay, and this process normally is used. Okay, so where there is a light load applications, okay, like a truck firings, okay, shower trays, okay, bath bulbs, okay, and caravana bodies, so maybe boat hulls, okay. So in a application where there may not be any load bearing capacity or load bearing requirements, so there we go with the this process, okay. So the next one will be the filament winding process. Okay, so filament winding process again, it's a example or a method in the processing of a composite material. So where we are going to have a continuous fibers. Okay, so as we seen in the spray layup, we can go with the continuous or a discontinuous. But when it comes to the spray up process, we are going with the discontinuous fiber. So this is a process where we go with the a continuous fiber process. Okay, so where this process is automated. Okay, so we can see the structure here. So here the important parts in this one is the mantle. This is a mantle, so which is going to decide the shape of the product which you are going to get. Okay, so if this is a cylindrical one, so the end product will be a cylindrical one. Okay, so if it is a conical one, so then that will be we are going to get a conical end product. Okay, so like that. So the product is decided by the shape of the mantle which you are going to mount here. Okay, so apart from that one, so we are going to have here as a nip rolls. Okay, so which will help to orient or pre-tension the fibers before wounding it on the mantle. Okay, so then we are going to have get a resin bath. Okay, so this is a open bath in which we are going to have a matrix mixed with a catalyst or a accelerator. Okay, so then we are going to have a fiber wheel. Okay, so again which are passed through a rollers, and then this whole thing is what you call mounted on a carriage wheel, okay, or a transverse wheel, so which is going to move in a to and fro motion. Okay, so this is going to move longitudinally. Okay, so means now what will happen here? So first the fibers are taken out of the creel and they are made to pass through a rollers. Okay, so where they are aligned in a proper direction. Then they are made to pass through a resin bath. Okay, so once they are taken out of the rollers, they are made to impregnate, or we are going to say like in a general term, they are dipped into a resin bath. So once they come out of the resin bath, the resin is coated on that one, so we call that one as a impregnated fibers. Okay, so those impregnated fibers are made to flow over nip rolls, so where we are going to remove the excess resin which is coated on the fibers. Okay, and these impregnated fibers are wound on the mantle. Okay, you can see the direction by which you are going to wound these fibers on a mantle. Okay, so it depends on the moment of the carriage or the strength of the end product which you want it at the end. Okay, so you can say like an angle of a wrap controlled by the ratio of carriage speed to the rotation speed of the mantle. So now, so the mantle is rotated along with the transverse motion of the uh, this carriage. Okay, so the carriage will be consisting of a resin bath and two sets of rollers. So one is a nip roller and one was a roller to control the what you call dipping of the fibers into the resin. Okay, so by controlling the ratio of this rotation to this linear motion, so we can control the distance at which we are going to wound these fibers on the mantle. Okay, this is something like the lathe movement. Okay, so where we are going to have the carriage linear motion, so rotation of the workpiece. So depending upon those things, okay, so we can calculate the feed, okay, the feed at which we are going to wound these fibers on the mantle. Okay, so normally once these whatever the fibers are wounded on these mantle, so this mantle is detached with these attachment, and then the mantle is shifted to a furnace. Okay, so shifted to a furnace where the curing of this material is going to take place. So once the curing is done, so then the material is detached with the this final product, and we are going to get the final product in the form of a pipes or a tanks. Okay, so sometimes if it is a complex shape, then we can have a wax mandrel, okay, where we can melt it and we can take out of that one, or we can have a metal or maybe the plastic one. So depending upon, or if it is a high temperature, we can have a ceramic one also. Okay, so which gets cured, and we are going to remove the final product from that one. Okay, so just like say like a, so we have a fiber on the from the creel which is going to come out of through the rollers into the resin bath, then to the nip roller to control the amount of resin which is coated on the fibers, then it is wounded on a rotating mandrel. Okay, so the compactness of the fibers on the mandrel depends on the rotation speed and the transversing speed of the carriage and the mandrel. So once the product is done, means once the wounding of these winding of these fibers is done, so then it is transferred to the curing furnace. Okay, so where it is heated to a particular temperature to get the required compactness. Okay, so then we are going to get the finished product. Okay, so now what are the advantages? So excellent mechanical property due to continuous fiber, so they are pre-tensioned. So high degree of design flexibility due to controlled fiber orientation and a lower cost of large number of composites. So this is a very fast and economic method of laying down material. The resin content can be controlled by metering the resin onto each fiber toe through nip or a dice. So as I said, the nip rollers are provided to control the amount of resin which is getting deposited on the fiber material. So limitation, difficult to wind complex shapes because the density by which you are going to wind these fibers on the mantle is difficult to control when it is a irregular shape. Okay, so poor external surface finish. The process is limited to convex shaped components, so fiber cannot be easily be laid down exactly along the length of a component. So mandrel cost for a large components can be high. This is a very important one. See, whenever we are going to use the mandrel, so the cost of producing the mandrel itself is high. Okay, so because ultimately the final product shape so depends on the mandrel material itself. Okay, or the shape of the mandrel. So producing the mandrel, if we are going to have a mandrel which is of a low cost, so then producing that one is a very easy. Okay, so low viscosity resins usually need to be used with the lower mechanical property, because if you are going to use a high viscous, then it will not get stuck to the fiber material, so it will just flow away. Okay, so in order to ensure that one, so low viscous materials are used. So normally this is used to produce the chemical storage tanks, okay, pipelines, gas cylinders, rocket motors, so launch tubes, pressure vessels, so missile cases, so drive shafts, fishing rods, okay, golf pipes, okay. So wherever there is a symmetrical way, okay, or a uniform structured components and all, so there we go with the use of this filament winding process. Okay, so easily one can choose from the variety of these process, okay, for producing the composite material. Okay, so the last one in this section is the sheet molding compound, or we can say SMC, okay, sheet molding compounding process. So where again this is a process which is limited for a discontinuous fiber. Okay, so we can see it here. Okay, so the arrangement maybe looks a bit complicated, but once you understand the process, then so writing the sketch as well as understanding the process is a simple one. Okay, so this is a normally extension of a compression molding. So we can say it here. So this is a one chain grade stoker, okay, or we can say carrier belt also, okay, so which will be continuously rotating, and we are going to have a carrier film here and one more here. So at the top and at the bottom, so we are going to have a carrier film, which is made up of a polyethylene films. Okay, so it will be helpful to what you call, prevent this, whatever the end product of the composite material from the environment, and to have the good surface finish also. So to ensure that one, so there will be two layers of a polyethylene film which are at the top and the bottom. And above this that is carrier film, okay, so we are going to have a tank from which you are going to pour the resin bath, that is a matrix. Okay, so above this carrier film, the resin bath is spread, and above this one, so we are going to have a setup from which we are going to get a chopped fibers, okay, of a required length. Okay, so that is a discontinuous fibers which are spread over the resin bath. Okay, so we are going to get a continuous strand roving here. So from that one, we are going to have a chopping mechanism. So we are going to get a discontinuous fiber which are spread over the one layer of a resin. Okay, and as it moves on, okay, so once again there will be one more a resin bath, so which is going to pour the resin bath along with the carrier film. Okay, so it is something like a sandwich. So we are going to have a one layer of resin. So one above that one we are going to spread the chopped fibers, and above that one we are going to have one more layer of a resin. Okay, so these are two layers along with the one layer of fiber are covered with the two layers of a carrier film. Okay, so once that the process is done, they are made to pass through a compact rollers. Okay, so the distance between these two rollers are going to control the thickness of the sheet which you're going to get it. Okay, so according to that one, these distance between the rollers is set. Okay, so once that one is done, okay, so we are going to have a gauge, okay, which is going to what you call control the thickness of the sheet which you're going to get, and then we are going to get a final product. Okay, so once this final product is done, so you can have a continuous one also, or you can chop according to the required length also. Okay, so then these things are used on a compression or a hydraulic presses to give a shape to the final sheet. Okay, so you can say like a sheet molding process involves placing a reinforcement such as a glass mat between a sandwich layer of a thermoplastic and heating the material to produce a single sheet of a material. Okay, so generally these SMC, that is a sheet molding compounding, is used. Okay, for producing electrical components or maybe fittings. Okay, so which are electrical insulators, okay, or maybe electrical switches, or maybe sockets, or panels, okay, or maybe caps, or maybe body panels, or maybe the what you call woods for automobiles. Okay, so all those things are produced by this process. Okay, so wherever, so this is something like a we are going to produce a raw material, so which will be used to give the shape to the shape depending upon the requirement. Let's say for example, if you want a car body cover, okay, so this sheet is used and it is placed over a mold, okay, in the hydraulic press, and it is pressed to give the required shape. So like that we can have a, this is going to act just like a raw material for a coming process. Okay, so you can see that one is a simple way like this also. Okay, so where we are going to have a carrier that is carriage belt, okay, polyethylene film, then we are going to have a resin filler bath, then we are going to have a chopping mechanism. Okay, so then again on that one we are going to have one more resin along with the polyethylene film, so we are going to have a compact rollers. Then, so as I said, it can be spread into a thin sheets also, or it can be rolled over a roller. Okay, so where it can be used for a further processing units. Okay, so now what are the advantages? So process are efficient, high volume production process. Okay, so SMP produces better surface quality and uniformity of a product. So high strength laminates, so ability to mold larger parts. Okay, so limitations, a large investment required for requirements, equipment, so more technology is required. Okay, so means so this whatever the process must be properly protected to prevent a toxic vapor emission. So whenever we are going to pour these molten resin, okay, so and when you're going to compact those at a high temperature and all, so a care to be taken to ensure that there will not be any vaporization of these resins. Okay, so once again, see all these process, whatever the process we have discussed. Okay, so again, so we are going to discuss few more in a coming section. So one has to choose. Okay, so depending upon their requirement. Okay, so it is not like so all the process are limited or can be used for manufacturing or processing of any type of the composite material. So it is not true in all the cases. Okay, so one can choose wisely to get the desired composite processing of a composite material. Okay, so we'll see few more classification in the coming section. So thank you.